Today's lesson is Workplace and Apprentice 30.4, Properties of Geometric Figures. We're going to start off with triangles. The triangle is one of the most important shapes in construction, manufacturing, and fabrication. Triangular structures are naturally rigid and do not easily change their shape, even when force is applied. Because of this physical property, triangular structures are used to strengthen everything from cardboard to skyscrapers. What structures have you seen that contain triangles? A triangle is a three-sided polygon found in three-dimensional structures such as roof trestles and shelf brackets. So a roof truss has lots of different triangle shapes in it. It makes it very strong to hold up the roof, and as well as a large amount of snow weight if that happens in the winter. Triangles are classified by their angle measure. So you can have an acute triangle. It means that all three angles measure less than 90 degrees. You can have an obtuse triangle. One angle measure is greater than 90 degrees, or you can have a right angle triangle. One angle measure is 90 degrees. You can also classify triangles by their side. So we can have an equilateral triangle, which means that all three sides and all three angles are of equal measure. Isosceles triangle means that two sides are of equal length and the two angles at the base are also equal length, or equal size. A scalene triangle, no sides and no angles of the triangle are equal. So, the choice of a triangle for construction or fabrication project may be based on the particular properties of the triangle. For example, if a steep roof pitch is needed, an isosceles triangle may provide the best roof truss shape. For a jump at a skate park, a shallow pitch is better, so an acute triangle may be best when represent the shape of the jump. Now, just remember that a pitch and slope are the same thing. Pitch we usually talk about as a roof, but in this case it's also discussed as a skateboard jump. Example 1. Lawrence builds and installs custom skylights such as those shown in the following diagrams. He needs to know the side lengths and interior angles of each face of the skylight so that he can accurately cut the glass and fit the pieces together. Calculate the measures of the indicated angles. So if we have three sides that are the same, in this case, then we know the three angles are equal. And then, therefore, they have to be 60 degrees each. Okay, this is an equilateral triangle. Okay, it's also an acute triangle because all the angles are less than 90. We have actually a right triangle here, and we have, which means that this angle is 90 degrees, and we want to know what angle A is, so we have 180 minus 90 minus 67 will give us the size of angle A. That makes angle A 23 degrees. Okay, remember that all triangles have interior angles that equal 180 degrees. You use that fact a lot to calculate angle sizes. Here we have 7 and 7, so we know that this is an isosceles triangle. Okay, that also means that these two angles are going to be equal. So we take 180 minus the top angle, which is 150. We're left with 130. 130 is going to be divided into two angles. Each are going to be 65 degrees. So angle B is equal to angle C, which is equal to 65 degrees. Okay, example 2, Sandra is a surveyor, and she's working in the Hudson Bay area, and she wants to be able to figure out the distance between points A and B, but there is a glacier erratic in the way, a large boulder. If she positions herself at point C, point D, or point E, she can measure the distance between her and points A and B. So she can measure this distance here and this distance here. So explain why Sandra is unable to find the distance between A and B by standing at point C or point E. So why do C and E don't work? Well, it's because a right triangle is not created. So she can't use that doesn't work. Can't use Pythagorean theorem. Okay, so the only time you can use Pythagoras' theorem is if you have a right triangle. That only works if she's in point D. Then we have a right triangle. So calculate if AD is 15 and DB is 20, calculate the distance AB. So AB, let's redraw that. So we're looking for this distance here, which is the hypotenuse. So A squared plus B squared equals C squared. 15 squared plus 20 squared equals C squared. Hypotenuse is always C. And so we have 225 plus 400 equals C squared. 625 equals C squared. And to get rid of the squared, undo it, we take the square root. So 25 meters is a B, the distance AB. All right, I'd like you to do some practicing with Build Your Skills. When you've corrected those and you've understood the material, move on to practice your skills, page 187, 188, question 1 to 3, and then there's 2 additional questions attached. Question 2, and the answer is provided here. So this is the actual answer. And question 3 with the answer.